Hello YouTube. So in this lecture 6P, I'll just be deriving the solution for the logistic differential equation so it makes a little more sense. So I just don't go throwing solutions without showing you how to solve them. And also, I'll be covering a few practice problems for those autonomous differential equations. So first of all, the logistic differential equation. So that's dy dt equals ky times 1 minus y over L. And I mentioned you had to do a partial fraction decomposition. So let's do that. We have dy over y times 1 minus y over L. Oh, sorry, not y. That's equal to k dt. So we want to try to integrate both sides. So first of all, let me just multiply everything by L so it's easier. So this is L dy equals y times L minus y. We can do that algebraically. So now we want to decompose this L minus y using partial fraction decomposition. So we can do that. So this is the same thing as saying a over y plus b over L minus y. So in order to do that, we can say that this is also equal to a times L minus y over y times L minus y plus b times y L minus y. So we have a times L minus y plus by equals L. Remember, L is a constant. L is the carrying capacity for our ecosystem. So we have AL minus AY plus BY equals L. So A is, so we basically have two sets of coefficients. We have the one for the constants where we have AL. We just have AL, and then we have plus negative A plus B times Y equals L. So here we can figure out pretty easily that A is equal to 1 because that corresponds to the L on the left and the right side. And then from there, since we know that negative A plus B must equal 0, because there are no Y, since there's the coefficient on the left side, but there's no Y's on the right side, negative A plus B must equal 0. So then that means that B must equal 1 as well, since B is equal to A if you just do algebra. So then this will equal 1 over Y plus 1 over L minus Y. So now we can integrate this. So let me just erase this because we kind of already know what it is. So we know integral of dl, or now we have 1 over y plus 1 over L minus y dy. Also, sorry for the noise in the background. I think parents are yelling at my siblings, probably. We have ln y minus ln L minus y equals kt plus c. So this is equal to ln of y over L minus y equals kt over c, kt plus c. Let's bring this to the top. We have y over L minus y equals e to the kt plus c, where we can just bring c here. Now comes the kind of hard part, I guess. So how do we make this just in terms of, how do we get a function of y in terms of t closed form? So we can multiply both sides by L minus y. So we now have c e to the kt times L minus y. Then we have y. We can distribute it out. So we have c times L e to the kt, where since L is a constant, we can this c times L becomes another constant. I'll just keep it as c, it doesn't really matter, minus cy e to the kt. We can bring this to the left side. So then we can distribute out the y. Actually, you know what? Let me just draw the L here to make sure, just to avoid any confusion. So we can divide both sides by this. So now we have by the 1 plus c e to the kt. I think I can erase this now. I think you guys know what's going on. So then this is L times c e to the kt. You don't have to keep L, but I'm keeping it there just for clarity, because may or may not be a bit difficult to understand what's going on. So now we can just do a bit of algebra, I guess. I mean, we're kind of where we need to be now. Just divide everything by c e to kt power. So now we have L over 1 plus, or sorry, we now have L over c e to the negative kt plus 1. Because if we divide everything by c e to the kt power, this thing becomes 1. This thing becomes 1. This becomes c e to the negative kt, and the c e to the kt and c e to the kt cancel out and just become L, or L over 1 plus c e to the negative kt. And that's what we were trying to find in the first place. So, or that's the solution that I showed you guys in the first video on autonomous lectures. Okay, so now that we're done with that, let's do some practice problems. And I'm not gonna even really bother with the deriving this whole formula for each practice on logistic differential equations. So I'm just gonna plug it straight in the formula and do the initial value problem, or the sufficient initial value problem analysis necessary. So first of all, let's just, do a practice exponential differential equation problem before we do anything. So let's say we have y prime equals negative 3y. And then we can just say that this is like, a bacteria. This model is a bacteria. No, not a bacteria. Maybe like radiation, something radioactive decay. So models like uranium or something like that, and how fast it decays. I know this is unrealistic, but I don't really care. This is just an example. We could say that we initially have like 8 grams. So this models how fast uranium decays. It doesn't. There's actually a constant that's verified, but let's just say this is just some random radioactive element and how fast it decays. Okay. So we could just divide everything by y first of all. So now we have this. But remember that this is actually dy dt. So now we can multiply both sides by dt. Then we can integrate both sides. ln y equals negative 3t plus c. So then this becomes y equals, you raise e to the power of both sides, so we have e to the 3t, negative 3t plus c. That's 3c e to the negative 3t. And then we can plug in the initial conditions. So y of 0 equals 8 equals c e to the negative 3, 0. So then that's c. So then c equals 1. Sorry, c equals 8. C equals 8. What the? I don't know what I'm thinking. C equals 8, obviously, because transitive property, I guess. I don't know. So then the solution is 8 e to the negative 3t. So a general rule of thumb is that if you get a problem like this, you don't have to do all these steps with separation of variables. You can just say that if you find a problem of the form dy dt equals ky, you can immediately figure out that the solution y of t is equal to c e to the kt, where c is the initial amount of whatever it is that you're solving for. This case, it's 8, so it's 8 e to the kt, and k is just that constant that we have here. So, okay. So now we can move on to practice logistic. I'm not going to cover any problems with logistic with threshold because that differential equation is too complicated and I don't want to have to deal with it. Maybe in another YouTube video that's not on this channel, you may find it. Probably not, but maybe. Okay, so let's say we have the differential equation 0.03y times 1 minus y over, say you had a carrying capacity of 800. So L equals 800. And this is equal to y prime. So let's say this models, I don't know, a population of chimpanzees in an ecosystem. Keep dropping that. Where their initial population is, I don't know, 300. So we want to find a differential equation. We want to find a solution to y that models these conditions. So how do we solve this? Well, we know L equals 800, obviously, because it's what's down here. We know K is 0.03. No, you're not always going to find differential equations in these forms. Sometimes you'll find it in a word problem where they'll give you K and they'll say that the carrying capacity is 800 and you'll have to figure it out yourself. But I just wrote it out for you so you guys won't have to figure it out. Although I should probably do that. So we know that the formula is y equals L over 1 plus c e to the negative kt. And again, I'm not going to bother deriving this formula because it's going to take forever, as you saw already. So carrying capacity, we already know 800 over 1 plus c, which we can figure out from the initial conditions, e to the negative k, so negative 0.03 t. All right, easy. So now we can just figure out the initial conditions. So y of 0 equals 300 equals 800 over 1 plus c e to the negative 0 power, because 0.03 times 0. I'm going to write it out just so you guys, just for clarity. So we get 800 over 1 plus c. Okay, so it's rather simple. We get 1 plus c equals 8 over 3. So we know c is 5 over 3. So then this becomes 800 over 1 plus 5/3 e to the negative 0.03 t power. Okay, that's enough differential equations for now. I'll see you in the next video. Thanks for watching. Sorry for the background.